Hello everyone, and thank you for checking out the complete beginners course in spatial data science and applications. That's Understanding Spatial Data Science Part 1. In Part 1 of this video, we will concentrate on understanding geospatial data science. To give you the concept of geospatial science, we will first of all look at related disciplines such as natural sciences, data science, and then discuss the definition of geospatial science and its unique aspects. Discuss the differences and commonalities between data science and spatial data science. For a better understanding, examples of problems in geospatial science are also presented. Does anyone know what science is? What is science? I present two definitions here, one from Wikipedia and the other one from Webster. According to Wikipedia, science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. Science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. This is the definition given by Wikipedia. Now let's look at the definition given by Webster. According to Webster, science is knowledge or a system of knowledge covering general truths or the operation of general laws, especially as obtained and tested through scientific method. What is the underlying differences between the two definitions given above? The core differences between the two definitions given above. One is focusing on activity or method, and the other one is more on subject. As a subject, science is a set of human knowledge on general truths. As an activity or a method, science is used in making reproducible observations and experiments based on careful measurements of the natural world. Traditionally, science method pursued finding causal relationship. In other words, it was used to answer why. Why is this happening? Why is this happening? For that, a hypothesis was set and tested with the experiment, which is precisely designed, particularly removing any biases. Sometimes other approaches could be used. No matter what, focus on scientific method was always on establishing causal relationships. Now, let's move to data science. Data science is the spotlight recently in the era of big data. Data science is growing with tremendous opportunities. A predicted 2.7 million open jobs in data analysis and data science related careers in 2020, source IBM. 29% growth in employer demand for both data scientists and data engineers by 2020. What is data science then? What is data science then? How do you define data science? How do you define data science? I'm going to give two definitions of data science. That's, again, one from Wikipedia and the other one from Cambridge Dictionary. According to Wikipedia, data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from noisy structured and unstructured data, and apply knowledge and actionable insights from data across a broad range of application domains. Data science is related to data mining, machine learning, and big data. According to Cambridge Dictionary, data science is the use of scientific methods to obtain useful information from computer data, especially large amounts of data. In the definition of the data science, there are three noticeable words. One is interdisciplinary, which means that data science requires understanding of multiple disciplines and the combination. Two, insight replaces truth in the definition of science, which means that data science is not pursuing general truths or general laws. Data replaces hypothesis and experiment, which means that data analysis is the major tool to find knowledge and insights. The term data science has been traced back to 1960 when Peter Neal proposed it as an alternative name for computer science. However, the definition was still in flux after the 1985 lecture in Chinese Academy of Sciences in Beijing in 1997. C.F. Jeff Wu again suggested that statistics should be renamed data science. He reasoned that a new name will help statistics shed inaccurate stereotypes, such as being synonymous with accounting or limited to describing data. In 1996, the International Federation of Classification Societies became the first conference to specifically feature data science as a topic. Then in 1998, Hayashi Shikyo argued for data science as a new interdisciplinary concept with three aspects: data design, collection, and analysis. So the three aspects are the data design, collection, and analysis. All in all, the focus of data science is placed on correlation. The focus of data science is placed on correlation based on the data analysis rather than causality. Data science generally does not try to answer why or cause and effect. So it is clear data science does not answer the question why or cause and effect. To become a data scientist, he or she needs to have expertise in a variety of disciplines, such as database management, big data system, such as Hadoop, should be understood for data handling and management, such as machine learning, data mining, data visualization, and application domain knowledge should be adhered to. Experience of data visualization is a big plus for delivering of results and visual analysis. Spatial data science is similar to data science in definition, but there's a major difference that spatial data science equally focuses on both causality and correlation. In other words, spatial data science pursues answers to the question why, and also a simple pattern of spatial phenomena. Spatial data science is also multidisciplinary, so that spatial data handling and management are important disciplines. With a given diagram, the relationship is also illustrated. Spatial data science has overlapped area with data science. At the same time, it has different aspects from data science, which is named as spatial science. We could find quite a few fields related to spatial data science, seeking knowledge of spatial phenomena such as urban traffic problems, healthcare issues, for example, regional prevalence of specific diseases, politics, business intelligence, city operation, hydrology, disaster vulnerability, emergency service, and many others. Let's take a look at real-world problem of spatial data science. What is the revenue estimation of a new restaurant located at Accra, Ghana? Or where is the optimal location of a new restaurant in Accra, Ghana? How can you get the answers to the questions? There are two approaches to this. One is causality approach and the other one is data mining approach. Causality approach based on spatial science investigates supply side and demand side, location and capacity with nearby competing stores are ascertained. Spatial distribution of potential customers are carefully mapped, and service accessibility models such as gravity model or two-step floating catchment analysis are applied. Finally, customer shares are estimated and eventually get an revenue estimation at a given location. On the other hand, data mining approach is to find the existing restaurants which has a similar pattern of new restaurants and then use the revenue of the existing restaurant as the estimation, or build a regression model of which target variables is revenue and input variables are characteristics of store and its location, and then use the model for revenue estimation. Which approach do you think is more appropriate than the other? In general, data mining approach works very well in case of small retail shops, such as coffee shop. On the other hand, causality approach works better for larger stores, such as grocery store, department store, and so on. The next problem is how long will it take to leave KNUSC for Amstead by Uber? At 6 o'clock p.m. Monday, there are two approaches in solving this spatial problem. One is the causality approach and the other one is data mining approach. Causality approach takes steps such as trip generation to build origin generation table, model split about decision making of transportation type, trip assignment to routes, and then get their travel time estimation. Data mining approach uses historical data sets of Uber trajectory, then find a similar trajectory which covers the origin KNUSC and then destination Amstead, and a similar condition parameters such as 6 o'clock p.m. Monday, weather conditions, and occurrence of any spatial events. Based on the trajectory of pattern mining and matching, the travel time can be estimated as well. The next question is, what is the air pollution level at KNUC at exactly 10 o'clock p.m. on Monday morning? There are two approaches in answering this question. One is the causality approach and the other one is data mining approach. The causality approach is to combine inventory of pollutant emission and weather condition into computational fluid dynamics and estimate air pollution level at given location and time. Data mining approach will train a machine learning algorithms which takes in air pollution data and produce air pollution map of a given condition. The last example is hydrological question. Where will be flooded in the city of Kumasi at 1 inch per 1 hour for 6 hours? Causality and data mining approach will be applied. We can use either conventional hydrological processes with spatial data, such as digital elevation model, which is a causality approach, or a heuristics data mining approach with pattern matching. There are four main disciplines of spatial data science. That's geographic information system, spatial database management system, spatial big data systems, and spatial data analytics. These topics will be discussed later. All right, this is the end of the first lecture. Hopefully you enjoy it and see you in the next lecture. Kindly subscribe to my channel to keep pushing me.